When you're finding the center of this circle, you will take the opposite of what sign's in there. So this would be -2, +3, and the radius is always the square root of the 64. So the radius of this will be 8. Another one, I'm not going to do every single one of these, but hopefully, so it's x minus 2, 5 plus 3 squared equals 16. So the center of this one would be +2, -3, and then the radius would be square root of 16, which is 4. Lila, I got you. No. Did I get you down? I got you down, Lila. Only one I'm missing is Casey, Mackenzie, Jolie, Abigail. Let me check one more time. Okay, yeah. And I talked to Chance. I know he's out. And then I guess Kayla probably, and then you guys said Hannah and Deanna are gonna be late for their meetings, so. All right, any questions about these? These were, like, some of you guys just missed parts of these. I'm not sure if it was just a sign or what happened on that, but a few of you guys just missed those. I did want to mention next Thursday, so not Tuesday, but Thursday, I'm probably gonna let you guys work online on Thursday. My son has a doctor's appointment we have one, my daughter has one and my son, one at 8:15 and one at 8:45. So I'm just worried I'm not gonna get back here in time, knowing the doctor isn't, and it's an ENT appointment, so they're always very slow. So I just don't want to risk not being back here in time. So I'm going to let you guys just do some work online, but I'll let you guys know ahead. But I just wanted to go ahead and let you know Thursday we probably aren't going to be in person. But I'll remind you guys of that on Tuesday. All right, we're going to go ahead and start 3.1. So you guys will get your notes out so we can start that. Your Moodle test that's on chapter 2 is going to be timed. It's about 20 questions, I believe. There's some multiple choice, some matching, some true false. And so you need to make sure you go ahead and have your notes out before, formulas out, so that way that you can get it done. If you have extended time on your test, I have already put that in there too. So you should have an hour to complete it. All right, we're going to start talking about 3.1 today, which is on functions. Yeah. All right, here's the mathematical definition of a relation. A relation is a correspondence between two sets. If X and Y are two elements, one from each of these sets, then a relation exists from X and Y. Then X corresponds to Y, or you could say Y depends on X. Don't let this stress you out. You've seen what a relation is. I'm going to show you some examples of this. Pretty much what we're saying is something like an equation, y equals 3x plus 1. This x, whatever x does, it changes y. So x is dependent on, y is dependent on x. So whatever you input here, y is going to be dependent, it changes based on what your x is. That's all that definition is. All right, you guys have heard of the word domain and range, right, of a relation. What would the domain be? Does anybody remember what domain represents? Can you tell me what they remember what domain is? It is your x-axis, but think about it as your input, okay? X values, which means your input. Range is your y values, which is going to be your output. You also think about domain as your independent variable, and range is your y. Yeah, this is input. Yep. Good job, Latrell. So domain is going to be your input and what you start with. It is independent, and your range is your dependent variable. So whatever you input changes your output, right? You put in 0 versus 1, it's going to change your output. So domain is your independent variable. Range is your dependent variable. All right, so we can represent a relation in different ways. Like I said, an equation is one way to represent it. We can also represent it in something called mapping. You guys heard of mapping before? All right, so this is a mapping of your hours worked versus your salary. Hours worked. This is salary, how much you make, okay? So we can use, this is called mapping, we can use this to represent a relation. We can also go from this to order pairs, so you can also use order pairs as a way to do mapping. So how would I write this mapping as order pairs? So again, we can use mapping as a way, we talked about an equation as another way to represent a relation. That's two. Order pairs is another way. How would I write these order pairs? Can anybody tell me how would I write these order pairs as from a mapping to an order pair? So 20 is going to represent what value? An order pair. The independent, which is your X, right? Okay. And Y is going to be your dependent, which is your Y. So if I was writing the order pair, the first one I would write would be 20 goes to 200. Does that make sense? All right, what's another order pair I would write? 20 to 300. Right? Then we're doing 30 to 400. And then we're doing 40 to 500. There's my little squiggly lines there. So I've got 4 order pairs that represent my mapping here. Questions on being able to go from mapping to an order pairs. Pretty straightforward, right? We don't, a lot of times we don't write it like this in mapping. We would normally write it as order pairs, a little bit easier. But questions on this? Everybody writing this down? So different ways to write a relation. We can write it as an equation. We can use mapping. We can use order pairs. You could also write it as a table. I didn't put a table up here, but you could also write it as a table. Graph would be another way to write a relation. Questions on this? All right, next definition we're going to talk about is a function. I've heard the word function before, I hope. All right, a function is a relation that associates an element of X with exactly one element of Y. So that means that you cannot have more than one X value, okay? If the X value repeats, it is not a function. Now the Y value can repeat, but the X value cannot. All right, take a look at these mappings, and I want you to tell me whether it's a function. So it's say yes or no, okay? Is it a function? Again, remember that the definition of a function is it's a relationship in which your x has exactly one element of y, meaning your x value cannot repeat. So if there's more than one x, it's not a function. All right. Anybody want to tell me this one? Is this one a function? Yes. Okay, why is it a function? Because there's exactly one x that goes exactly one y, okay? How about this one? Is this a function? Anybody from Nurse Club? All right, Latrell said yes. There's only exactly one x. Does that make sense? 1, 1, 1, 2, 1, 3. This goes to 1, 5. This goes to 2, 5. This goes to 3, 6. Now, the y value repeats, but that's okay. As long as you have exactly one element of x, okay? What about this one? All right, Phoenix said no. So notice here, the 1 goes to the 4 and the 5. So that means your x value repeats. So therefore, it is not a function. Questions on this? We need to make more examples, or we got it? Let me give you a couple more. Can I erase this? Y'all good? Didn't get it, go back and look at the recording, okay? All right, let's do, all right, look at these two examples. Put yes or no. All right, is this one a function? No, I said yes. All right, let's look at our x values. We got a -1, a 4, a 3, and a 5. None of them repeat, therefore it's a function. All right, how about this one? The second one is no, okay? So we look at our x values, we have a 0, a 3, a 1, a 0. This one has x value that repeats, so therefore it is no. Questions on this? All right, what about an equation? How would we determine whether this equation is a function? How would I figure that out? Does anybody know? What could I do to determine whether the equation is a function? Well, we can graph it, right? So on this, your slope is 2, your y-intercept is 1/1, right? So if I graph this, my point here. Rise up to the right one. Two. And we can also go down to the left one. Looks like this. Does anybody remember a test that you could do? There's a test that we could do. Remember what it's called? Anybody heard of the vertical line test? You've heard of that, right? So we can use, so the vertical line test is used. If it passes the vertical line test, then it's a function. Passes vertical line test, then it's a function. So on this one, if I drew a vertical line down this, anywhere I go, it's only going to touch one time. Okay? So if it touches, right, Latrell, if any of the points touch more than once, it's not a function. So look at this. Anywhere I draw my pencil, sometimes you also heard it called the pencil test. Like if you lay your pencil on it, anywhere. Now, can anybody tell me something that we've covered recently that would not pass the vertical line test? Something we just talked about that would not pass the vertical line test, meaning it's not a function. Good, Phoenix, a circle, right? We just talked about circles, right? If I drew my vertical line test, how many times it's going to touch? This one touches twice. Okay, so it doesn't pass the vertical line test. Now, here's a good question. I want you to think about linear equations in general, right? Think about your linear equations. You draw, there's a linear equation, there's a linear equation, here's a steeper one, there's a steeper one. What is an example of one type of linear equation that would not be a function? Meaning there's one type of equation of a linear function, of linear equations that would not pass the vertical line test. That's not a function. Can anybody think of what it is? Because it looks to me like all four of those would pass, right? There's one type of linear equation that would not pass the vertical line test, meaning it's not a function. There's only one type. I got an idea what it would be? Latrell, you got a 2 up there. What do you, I don't know what you mean by 2. Anybody got an idea? Oh, I got you. Yeah, you're right. Sorry. Anybody have an idea of what kind of linear equation would not pass the vertical line test? There's only one type. I got no answers. I guess that means y'all don't know, right? What about this one? What is that? What kind of equation is that? Well, what way is this going? Up and down, which is what? What line is it? This will be x equals 2, which is a vertical line. Now notice if I put my pencil up here and I drew a straight line, it's going to touch everywhere, right? Think about it. You put your pencil on this, it's going to touch at all the points. So it's not going to pass the vertical line test. So the only type of linear equation, now look, think about a horizontal line. If I draw a horizontal line this way, it's going to pass because it only touches once, right? So the only type of linear equation, so all linear equations are functions except for a vertical line, a vertical equation. So y'all need to write that down somewhere. All linear equations are functions except vertical lines, which is your x equals a number. Okay. All right, we know circles are not functions, right? There's some other examples, but. All right, so another definition, the value of f at the number x is denoted as f of x. This is called function notation. So like, instead of writing your equation as y equals 2x plus 1, if I already know that this is a function, we can write this as f of x equals 2x plus 1. And that tells you right there we know it's a function, okay? So technically, y represents the same thing as this f of x. So we can say y equals f of x. That's called putting something in function notation. Okay, why do we use this? Well, we can find different things using function notations, and we'll go over that in just a second, but make sure you get this down. Using function notation just makes things a little bit simpler, and we can solve problems using function notation. You got it? All right, so let's look at a problem where we're going to use function notation. We're going to solve. Function notation, again, is just another way to write stuff. And it tells you it's already a function. So let's say I've given you guys f of x equals 2x squared minus 3x. And then I'm going to find these different parts. I'm going to find f of 3. I'm going to find f of x plus f of 3. 3 times f of x. Negative x. Negative f of x. X. All right, write that down and then we'll start going over it. Is a nurse, but is Caleb there? And Jen and Hannah, Caleb wasn't at the meeting. Thank you. Okay. All right, we ready to try some of these? So when you read f of 3, remember, think about it, f of x is our function notation. This means that 3 will take the place of the x. So when you write your equation now, you're going to write it as 2 times 3 squared minus 3 times 3. Wherever there is an x, you replace it with a 3. Okay, everybody understand this one? So this is going to be what, 9 squared, 3 squared is 9, 9 times 2 is 18, 18 minus 9 is 9. All right, any idea how we would do this one? It says f of x plus f of 3. We've already found f of 3. But how would I write f of x plus f of 3? Any ideas? Well, what is f of x? Huh? No. Look at the equation up there. Yeah. So where there's an f of x, we're going to write the equation, right? So it's going to be 2x squared minus 3x. Then I just found f of 3. What was f of 3? No. So that is our final answer. Does that make sense? So 2x squared minus 3x plus 9 would be our f of x plus f of 3. Okay, leave it like that. All right, how would I do this one? This is saying 3 times f of x. So we would do 3 times, what is our f of x? 2x squared minus 3x. Now, do I leave it like this? No, it's not simplified. So we would do 3 times 2x squared is 6x squared. 3 times negative 3x is negative 9x. This would be your answer. Questions on this? All right, how about D? How would I do f of negative x? Well, you don't want to change the number in the front, but this is saying instead of putting an x into your problem, you're going to input a negative x. So don't change it on the outside, but you're getting somewhere with that. So 2, this becomes a negative x squared minus 3 times negative x. Does that make sense? Now notice this problem is talking about what you talked about, okay? So now we have to simplify this. What is negative x squared? What would that be? What's negative x squared? Saying negative x times negative x, which becomes a what? Positive x squared. So this becomes 2 times positive x squared, and then you got a negative and negative, which is going to make a plus 3x. Questions on that one? Good job, Latrell. All right, what about this one? This one's a little different. You're taking a negative and you're multiplying it by the f of x. So up here, where your equation is, it's like saying, oh, this is like negative 1 times that. Does that make sense? So it's kind of like you're flipping on the sides. Okay, so this would be a negative times 2x squared minus 3x, which then becomes negative 2x squared plus 3x. Questions so far? All right, what about f? What do I do with f? You're, I'm hearing you. But tell me what you said 9 something. So what do you do with this? think about, instead of a x here, it's a 3 times x, right? So wherever there's an x, you're gonna put 1 in there. So think about this problem, right? This is where the x is, like think about F3. Wherever this 3, wherever the x was, you put a 3, right? So instead of an x there, we have a 3 times x. So wherever there's an x, what are we gonna put in the spot? That makes sense? Now, I heard you saying 9, but you're thinking 3 squared, 3x times 3x, which would be a 9x squared times 2 minus 9x. Are you with me? So again, guys, whatever is here, if this is 9x, you're putting a 9x in both of these. If this is a 100, you're putting 100 up here. If this is a 0, you're putting a 0 up there. If this says 3a instead of an x, you would put a 3a up here. Okay? Now this reduces to 18x squared minus 9x. We need to simplify it. Okay? And what about e? What am I putting in that one? How would I do this one? Gosh. Honestly, Latrell, I just saw it and I just kept on going. But just oh, all right. How would I do x plus 3? Any ideas? Are we just not getting this? Everybody's getting this? Everybody's just done. All right. Instead of x here, we got an x plus 3. So instead of x, what are we putting? X plus 3. Now it's like this. Do we know how to simplify that? We should. So this is 2 times x plus 3 times x plus 3 minus 3 times x plus 3. We can FOIL this or box it, right? X times x is x squared, x times 3, 3x, 3 times x is 3x, 3 times 3 is 9. And all of this is being multiplied by 2. 3 plus 3 is 6x. Minus this negative 3 is going to go to B both. Negative 3 times positive 3 is a negative 9. And we're going to simplify this. 2 times x squared is 2x squared. 2 times 6x is 12x. 2 times 9 is 18. And then I have my minus 3x minus 9. Is everybody with me? And then I end up with what? 12x minus 3x is 9x. 18 minus 9 is 9. So I end up with 2x squared plus 9x plus 9. Questions on these? So these are some different things you can do with function notation. There's something called so there's 2 different forms. If we use function notation, it's called explicit form, and implicit is when you use your x or y. So just write that down. Implicit form uses x and y. Explicit uses fx and x. So again, how would I do that? For example, y equals 2x minus 1 is implicit. F of x equals 2x minus 1 is explicit. So two different ways to write it. These mean the same thing, okay? All right, we're running out of time, and I don't really want to start the difference quotient. We don't have enough time to get through it. So I want to talk about difference quotients with you guys, because it's important if you're going to take calculus after a trig, which hopefully some of you will. So we have a little bit more to get through, and we need to talk about domain specifically and how to find the domain. And then also properties of functions. So this is a long section. 3.2 is really short. So I am going to, my plan is next Tuesday, we'll finish 3.1 and cover a little bit of 3.2. Next Thursday, I may give you guys a practice worksheet on actually doing more of this. Which you guys, you feel like you need a little bit more practice on this stuff? Yeah. So that will be my goal for Thursday, is I'll give you guys a worksheet to work on for this. And then, the other thing you guys need to be working on is your test for chapter 2, and then wait on the quiz until after we finish on Tuesday. Okay? All right, questions? Anybody have any questions? We're ending a little bit earlier just because I didn't have time to, I don't want to start something that we won't have time to finish, but, all right, I will see you guys on Tuesday. Go ahead and start working and finish it. Your test has to be done in one sitting. So like it's an hour. So you have to complete it in that hour time. You can't start it and stop it. Okay? So make sure whenever you take it, you have plenty of time to do it and you have reliable internet. All right? Okay. We will see you guys on Tuesday.